Most of us grew seeing cartoons and movies of Spider-Man, but have you ever realized that physics are applied by the superheroes at all time? The relation of the superheroes with the physics has been very narrow from the beginning, and in this video we will demonstrate it. Our questions are: what tension do the webs need so they don't break? What is the velocity Spider-Man has right before he touches the ground? At what launch speed does the web need to be launched in order to get attached to a building? How long will Spider-Man take from the place he's standing to the place he's landing? Which is the force Spider-Man exerts to the floor on his way down? Our hypothesis is that the web launched by Spider-Man is supernatural because there is no web that thin which supports the weight of a man. Spider-Man reaches high speeds because the length of the web is very long and he has a very high torque.
To obtain the tension, we're going to subtract t times sine of 50 minus 735.75, and then we're going to solve sine of 50, and then we're going to divide 735.75 by 0.766, and that's the tension.
The formula we use to get our final velocity is velocity equals initial velocity plus acceleration times time. Then we substitute it with the values we get from the video and we get the result of 104.595 meters per second.
For launching speed, you use your formula delta y equals VOT plus a half of gt squared. You have your data, delta y, t, and gravity. You substitute this formula and solve for VO, leaving you with the initial speed of 36.875 meters per second.
Considering the data before given, we use the formula of velocity equals initial velocity plus acceleration times the time, and we divide 104.595 over 121.622, and that equals to 0.86 seconds.
Which is the force that Spider-Man exerts to the floor on his way down? If Spider-Man's weight is 75 kilograms, applying the Newton's first law of the product of the mass times the acceleration, this is the weight of the superhero times the gravitational acceleration equals to 735.75 newtons.
To answer the question, what tension do the webs need so that they don't break? We use the physical principle of tension force. The tension force is the force that is transmitted through a string, rope, cable, or wire when it is pulled tight by forces acting from opposite ends.
For the second question, we use the velocities principle, which is the displacement that an object or particle undergoes with respect to time.
Which is the force that Spider-Man exerts to the floor on his way down? In order to solve this, we apply Newton's second law, which states force equals the product of the mass times acceleration.
To answer question 3, we use the principle of physics called motion in two directions, also known as projectile motion. This is when we have an object that moves in the x and y direction. It also moves, forming the shape of a parabola. Air resistance and rotation of the Earth are neglected.
The answer to our hypothesis is that Spider-Man's web is supernatural because a regular spider web has a force of 4.905 times 10 to the minus 3 newtons, whereas Spider-Man's web needs to have a force of 960.509 newtons to carry our superhero.
Like any other superhero, Spider-Man has superpowers and a superweb, but physics are always applied. In this case, the tension, acceleration, velocity, torque allow him to move from one building to another.